Okay, so in these 4 slides, what we're going to talk about is how the nephron loop works. Okay, the nephron loop, you're going to remember, is just this part, so the descending and the ascending components of the nephron. Okay, now its main job, what it does is it's going to help us conserve water, so we're not peeing out 100 liters of water a day. Okay, the way that it does this is it's going to make a salt gradient. Okay, so it's going to be make a salt gradient, and that salt gradient is going to allow the collecting duct, which is not considered part of the nephron, to concentrate your urine. So water and ions are what we have to focus on here. Okay, so remember we have the thick segment and we have the thin segment. Okay, the thick segment is permeable to sodium, potassium, and chloride. Okay, it's also impermeable. Okay, so water can't go through it. The only thing that can go in and out of it are these ions. Okay, the thin segment is the opposite. Okay, so it's permeable to water. Okay, but not the ions. Okay, so that's going to allow us to make a concentration gradient and move water around. Okay, so this is a picture from an old book, and I want you to see, okay, so up here, this is thick, and then this is thick. Okay, so the numbers in here, they're referring to the osmolarity of the filtrate. Okay, so how concentrated is what's in the urine, okay? You guys don't have to worry about knowing those numbers. You just need to see how they change. And they make the picture, the colors change, right, when the urine gets more concentrated. Okay, so the PCT, we're adding salt. Okay, so we're adding salt all the time. Okay, now this says the higher the osmolarity of the extracellular fluid, the more water leaves the descending limb by osmosis. Okay, so down here where it's thin, if we have a high salt out here, water's going to leave. Okay, and water leaves, so as the water leaves, that means that the filtrate is getting more concentrated. So you can see these numbers going up: 400, 600, 900, 1200. Okay, so that's what this says. So the more water that leaves the descending limb, the saltier the fluid is that remains in the tubule. Okay, and then as we go back up, okay, we're going to get to a different, right, we're back at thick. Okay, so as we get up through the thick, the ions leave. Okay, so the saltier the fluid in the ascending limb, the more salt the tubule pumps into the extracellular fluid. So these ions leave, and they stay in the medulla of the kidney to maintain this concentration gradient. Okay, so we need these ions in the kidney in order to make sure that we don't lose all the water. Okay, so then what will happen, so the more salt that's pumped out of the ascending limb, the saltier the ECF is in the renal medulla. So the next picture shows it again. So let me show you. Okay, so, this is continuing on. Okay, so what happens, okay, so if it stays salty out in the medulla, okay, so it's salty out here, what's going to happen is water's going to leave the collecting duct and go into the kidney, and it'll get picked back up by the blood. Okay, so osmolarity gets more concentrated, so 4 times as concentrated deep in the medulla. So you got more salt the further in you go. The medulla part of the collecting duct is more permeable to water than to the sodium chloride. So the collecting duct, what it's doing is we're reabsorbing water to concentrate our urine. Okay, now this picture is from our book. Okay, so these two things, this process, what's going on in the nephron loop actually has formal names, and they call it a counter current multiplier, and then there's counter current exchange. So the idea is, okay, we have this thick part of the descending limb, okay, which is permeable to the salt. Okay, and then we get down to this thin region, which is going to be permeable to water. So water's going to leave the nephron loop. It's going to go into the extracellular fluid, and it'll go into the capillaries. Okay, and then as we go back up, okay, this thick region is permeable to salt, so the salts will leave, okay, and that'll go into the tissue. And then we'll end up like back to like a normal concentration, so we're not peeing out super duper duper concentrated urine. So it's maintaining the concentration of the urine, and it's maintaining the concentration of the blood. So I hope that makes sense. What I want you to know is it's all about salt and water here.